we are. Okay. So there's question number 5. So go ahead. Let's run back over the method. This is what they're saying in this problem. They're giving, here's a voting schedule thing, preference schedule it's called. Rank the candidates using the extended plurality method. Extended just means like, don't just find first place, but find second, third, fourth. Just, I think it'd be pretty obvious for you. So let's just go ahead. Here's the answers. But let's go ahead and do it. Go up here. Suppose this is what you'll see on the test. You'll be given a big preference schedule like that, and it'll say, okay, use that to do the plurality. So let's go through the different methods. Just be a good little quick review. So plurality method first off. Can we do plurality on that? You guys have your own paper there. Let me give you a second. Let's go through the methods. So first method, plurality. So go ahead and do plurality. And to do plurality, that just means keep track of how many plurality is just first place, right? That's like how we do president. First place, it's all we care about with plurality method. So we're just going to go person by person. So how many first place votes did A get? All I'm looking right now is right. Yeah, right, 7. So A got 7. All I'm looking at is that top row, first place. That's plurality method, huh? We just care about first place, like when you vote president. They don't ask you your second, third, fourth choices. So B, how many first place did B get? Actually 5 and 4, huh? So 9 altogether. First place votes. And then C got just the 5. D got the 14. All right. So who wins the election if you do the plurality method? D. D's obviously first choice. Now who comes in second place? The B, right? Second, and third is A, and fourth. So that's what we're doing over here. A comes in third. See how A is third. B comes in second. B is second. C comes in fourth. See how C is fourth. And D comes in first. D is first. That's all they're wanting you to do for that first one. Just go ahead and do plurality method and give them their ranking, right? A came in third place, B came in second, C came in fourth, D came in first. That's their ranking. That's what they mean by extended plurality. All these are just going to ask us to do extended, which means don't just give the winner, but tell us second place, third place, fourth place. That's pretty easy to do. Want to do the second one? Let's do the part B, board account. So now they can say, all right, redo the election. This time, do the point system one called board account, where you give the points. Let me let you do that. Then I'll jump in just a second. Be good little. If you have a calculator, this is the one that's a little more tedious. Going to want to use a calculator on that. So I'm looking at the schedule. On the schedule, everybody get a schedule? Last time, anybody need one of those? The calendar? We get that? All right, well, if you didn't get it, come up after class, right up here. Anyway, according to the calendar, we're supposed to have a practice exam next Thursday. So we're going to take a practice exam next Thursday, and then a week after that, we take the actual exam. Yeah, that is the plan. All right, you guys getting that okay? Remember how all that works? So let me actually get a fresh screen here. So we're going to do the board account. So how's the board account work? Remember, it's the point system. How do you lay out the points?
4 times 14.
Yeah, you start at the bottom. Yeah, start at the bottom and you go, okay, if you get, it's like GPA. You get a 1 if you get fourth place, then 2 points. This is the points here. 3 points and 4 points. You start at the, if you get last place, that's 1 point, and then next to last is 2 points, and then on up the line, right? You start at the bottom, and you see you get 1 point for last place, and just go on up the line, and then you just figure out the points everybody got. So let's do A first off. So this is board account, the point system. So how many points did A get? Well, A got 14 people put A last. So 14 people gave A 1 point. You with me so far? right? 14 people voted D was their favorite, followed by C, followed by B, followed by A. That means 14 voters felt that way, right? So 14 people put A last. 14 people gave A 1 point. And then the next group, the 7 people, they gave A 4 points each. So you just add these up, right? Plus 7 times 4.
Wait, which one is this one for?
This is the board account. This is part B. So I'm doing board account right now. Doing the point system. So we finished part A. I'm on to part B. They're going to have us just go through all 4 methods just to make sure we got them all straight. See what I'm doing? In the point system. The next 5 people, where did they put A? They put A last. So 1 point each. The next 5 after that put A at 3 points because they put him second. And the final 4 people put A at 2 points each. So there we go. Whatever that adds up to be, that's the total points A gets. We good so far? Somebody got that in their calculator?
70 for A.
A 70? So it come out 70? All right, sounds good. So it comes out 70 for A. Want to do B? So see how many points? That's the total points B gets. Try B. Find total points for B. Good. So B's right here. 14 people gave B 2 points each. And 7 people gave B 3 points each. And 5 people gave B 4 points each. And 5 people gave B 1 point each. And 4 people gave B 4 points each. So we got B's total?
90.
90. All right. B is 90. So B is winning. B got more points than A. Let's keep going. We got to do C and then D. So now let's go figure out all the points for C. And then D. Okay, so for C, so 14 people gave C 3 points, and 7 people gave C 1 point, and 5 people gave C 3 points, and 5 people gave C 4 points, and 4 people gave C 3 points. So we got that total? 96. So C's winning so far. Last comes D. So now let's figure D's total. And so 14 people put D first. Ooh, D's got some points. And then 7 people put D at 2. And 5 people put D at 2. And 5 people put D at 2. And 4 people put D last. All right, somebody got a D total?
94.
90. Oh, not quite winning, huh? All right. So there we go. So there's the election by the point system board account. So so A came in 4th place. Right, with only 70 points. A is the worst. See how we got A's ranking here? 4th place. Right, you're supposed to give the ranking, what place they came in that election. So A came in 4th place. A was the lowest. B came in 3rd, right? B's total of 90 was the 3rd highest. C came in first, 96, that was a big winner. And then D came in second with 94, that was close. Good on that? Remember the point system? The board account? So that comes out a little different, huh? You can see how which method you use is going to determine a different winner. It's going to determine a different result. And the whole question is, what's most fair? What's the fairest way to do it? Because it's going to determine a different result. What's really the will of the people? That's what we're trying to do here, right? If the people really vote this way, what does that mean about them? I mean, fairly, honestly, truly, what does that really mean? Who do they really like best? Who do they really like second best? Well, it's been a thorny question. It's been a difficult question, hasn't it? Kind of depends how you look at it. That's what we've been seeing in this chapter. All right, we good with that? Shall we do the third method? We good with the second method? So first method is just plurality, just first place votes. That's like how we do president. And we thought that was unfair because it doesn't even take into consideration your feelings about second, third, fourth, or fifth, or whatever. So then they came up with a new system called the point system, board account. That's this one. That's got some good fairness to it. We did see something that was weird about it. Was it last time or the time before? Where it did something weird, where somebody dropped out. That's what it was, right? Somebody dropped out, and then it made a different winner. And that didn't seem fair. So that's why the math people kept looking like, oh, that's kind of not fair. If somebody drops out, that shouldn't change the result. I mean, if it's somebody unimportant that drops out, that shouldn't change the winner. It did. So that seemed kind of unfair, not good. So they kept looking. Then they came up with a third method, plurality with elimination. And that was the round by round, right? They just keep kicking out the low guy. And they use that for the Olympics, as we talked about, when they pick an Olympic host city. And B, the board account, they use that for a lot of things, picking a lot of sports things, Rookie of the Year and MVP and different sports and stuff. So they do that. So let's go do the third one. So the third one is plurality with elimination. Plurality with elimination. So give that a try real quick. Remember, that's round by round. So let me come up here. We're on part C now. Plurality. And then we'll do the new thing. So all this is review. And then I'm about to dive into the fourth one, will be new. We've only got one more to go. So this is the third one. We've covered this. See what you remember. Plurality with elimination. The elimination, hopefully will help you remember. That's where you keep eliminating. This is how they pick the Olympic host city. And the word plurality, what does that mean? First choice only, huh? Whenever you see plurality with anything, that means just first place. They don't care about second, third, or fourth. So I'm just looking right here, and I'm saying, okay, here comes round one. Let's call this round one. Round one, we got A, B, C, and D. A got what? 7. This is just like what we did up in the plurality method. At least round one is the same. B got 5 and 4. 9. Yeah. C got just the 5, and D got the 14. Okay, but the difference is we don't just stop and say, okay, D wins or whatever. We just do round by round, right? That was the thinking. That's how people were thinking. They were thinking, okay, the plurality method's not fair because it just takes first place. Board account's not fair with the points because it made something weird happen when somebody dropped out. So they thought, why don't we just do like round by round and we just always kick out the low guy? That'll be fair, right? We're just always just getting rid of the bottom one until the end. So who is for sure not the will of the people? C, right? That's kind of the thinking with this method. They just thought, look, you can tell that C is not the will of the people. That's what we're supposed to be determining here. So drop C out. So C is going to come in last place. So we know right now C's ranking is 4th. See it down there? C is the worst. C is the lowest. C dropped out in the first round. It's like when you play in a tournament, you lose in the first round. You're out. All right. I played tennis in junior college, and then at the end of the year, all the schools get together and they play a gigantic tournament. And I played high school, and then I played junior college, and I was not that good. I was like middle, lower than middle, a little below middle. It was hard. There's a lot of good players. Anyway, and I always wanted just to make it through the first round was all my desire in the end of the year tournament. Because I don't know if you know how tennis works, but half are eliminated first round. Everybody plays everybody, and all the losers are done. It's single elimination. Then you go, it just keeps cutting in half every round. I thought, I just want to make it through one round. It was like the end of my tennis career. And I went out there, and the first round, I just got... I lost the first round my first year. Second year of junior college, I went out to the big tournament again. The first round, I got my seed. I saw who I was playing. I went, oh, not that guy. He's really good. And he'd been hot recently in recent matches. And he just cooked my goose, like 6-0, 6-1. I can't remember what it was. I thought, first round again? I can't even get by the first round. Anyway, so you're a loser if you go out in the first round. So he's out, so he's fourth place. All right, so go on. So do the next round then. So the next round, round 2, we're just going to go A, B, D. A, B, D. Now, things are going to shift a little bit because we're dropping C out of it. So let's drop C, right? Because C's out. So come back up here, drop out C. Because C's out. And you see what that'll change? See how these 5 people, now their favorite is A? Because it used to be C, but C's out. So that will change first choice a little bit, right? A will now have what? 7 and 5. A has now 12 people that like him best because C is out. So that causes some shifting. That does consider lower level priorities, you see. It's not like the plain plurality method, which never looks below the top line. This method does consider your second, third, fourth choice feelings when other people drop out. So, round 2, how many did B get? B got 5 and 4, 9. That didn't change. D didn't change, 14. All right. So, that's round 2. Now, again, we drop out. We eliminate the low guy. Who's out? B. Yeah, this time B is out. Surprisingly, we were thinking we might drop out A, because the first round A was the second lowest, but things shifted in round 2 because reasonably so, because A is liked pretty well by some people in second place, and that kind of showed up, which it should, right? Maybe they're not everybody's favorite, but they're pretty well liked, and that helped them out here. So now we go to the final round. So that would mean B. B is third ranking. See the answer for B down there? B dropped out second, so he's ranked second to last. And now A and D. It just comes down to A and D. Go over here to the table. Drop out B. Drop out B. B is out of the tournament. B is out. Okay. Now, how many did A? A gets 7 and 4, right? That's it. Oh, and 5. 12. A gets 16. D gets 14 and 5, 19, right? Yeah. So D wins. So D is first place, and A gets second place. That makes sense then? How to do it? The round-by-round method? That's what they do for Olympic host cities. Probably some other things I don't know about. But there we go. So we got 3 methods. D has won 2 of the different methods, and C won when we did the point system, right? So we've had some different results, depending on how you do it. Question is, what's really the will of the people? This seems pretty fair. There is something weird it can do too. We'll see that today, so we better get moving. Now, it's time for this. So in a little bit, I'll show you what's weird. There is one thing that this method does weird, although it seems pretty solid. The Olympic Committee likes it. But it does have the ability to do a weird thing, which we'll see in a few minutes. But before we do, let's go on to the last method. So they kept searching because this one did something weird, which we'll see in a little bit. They said, let's try again. And then the 4th method, the last one we're going to look at, that math people came up with to help determine the will of the people faithfully, is, what is it called? It's where you do the one-to-one comparisons. I forget the name here. What is it? Pairwise, that's it. So here we go. All right, so so D, pairwise. Now this is kind of a pain, unfortunately, because it's like a big tournament. You got to do a whole bunch. Well, yeah, we just barely started it, didn't we? That's right, I remember now. So you got to do all the matchups first off. So you got A, B, C, and D. So you started A. Remember, I said do this with a system so you don't accidentally miss any. So it's A versus B, and then just go down the line. A, C, A, D. And then that's all the A's, right? That's A against everybody, A against B, C, and D. Now you got to start with B. And remember, you never need to go backwards. You don't need to go back to B, A, because A and B are already playing each other right there. Right, just go forward. B and C, B and D. And we got all the B's, because that's everybody with B, right? Now start with C. And again, you don't need to go back. You don't need to do CA or CB, because CA's right there and CB's right there. C's already played them. Just go forward, CD, and that's it. Don't even need to start with D, because D's already been done. So there they are. There's all the matchups. That's everybody versus everybody, like a round-robin tennis tournament thing. Okay, so now we just got to see who wins one-to-one matchups. So how do you do the one-to-one matchups? Well, you remember how to do this kind of thing? You just look at the table only with A and B in mind at first. You don't care about how they feel about C or D, just A and B. So like these 14 people, if it's just between A and B, who do those 14 people like better?
B.
They like B, so we give those 14 to B. Right, see what I'm doing? Now the next 7 people, if it's just between A and B, who do they like better? They like A, give those 7 to A. These 5 people, if it's just between A and B, who do they like better? B, right? The next 5 people, if it's just between A and B, who do they like better? A. And the last 4 people prefer B. So B was 18, 23, and A got 12. So B certainly won that, right? If you ask, you could see the thought here. The thought behind this method is, look, if you want to faithfully determine the will of the people, we do. That's the whole point of trying to come up with a good system. Is what's the will of the people? What you should do is just have one candidate versus the other. Like we should have just had Hillary and Trump and just those two, and don't vote on any third options. Well, that's pretty much what we did. There are other options anyway. So, and the European, I don't know if you know the European system. A lot of those countries, they have several candidates that are close. It's not as much just 2 candidates like it always is in America. They'll have like 3 or 4 candidates that'll all get a fair chunk of the vote. Anyway, so this method is saying just put 2 people. Forget about everybody else. Just do 2 at a time and determine the will of the people. So, hey people, all of you 14,7,554 people, what if we just had A versus B? How do you all feel? They're like, well, if it's A versus B, we like B better. 23 versus 12, right? So we have determined, so this is an attempt, another method to try to really be fair with the will of the people. So hey, we like B, so I'll say B wins that one-to-one matchup. But that's just the first one. And we got to do the next one, and the next one, and the next one, and the next one, all the way down. So really, in real life, computers do this. So next, let's do A versus C. Can you do the next one? Go ahead and do A versus C. So look at the people, determine their will. If it's just A and C, add them up, see who they would prefer. And you can just keep going down the line if you want. So the 14 people, first off, who would they prefer who do they like better, C or A? They like C, right? Everybody see how I'm doing that? And the 7 people, they like A better than C. The 5 people, they like C better than A. The next 5 also, I think C's, you can stop as soon as you can tell. I mean, C's killing them, huh? It's like totally C. You don't need to you don't have to get all the totals. Just as soon as you can tell which one wins the tournament or the match, then boom. So C won the battle with A, head to head. So we're asking the crowd, the will of the people, if it was just A and C, who do you like better? They're like, well, we like C better than we like A. That's certainly true. That's the will of the people, right? When we added them up. Let's do the next one. How about A versus D? So this one's pretty tedious, a lot of adding up. So A versus D, so the 14 people, they like D. The 7 people, they like A. The 5 people, they like D. The next 5, they like A, so it's a little close here. The last 4, they like A. Hey, maybe A won that. Did he? 16, oh no, 16, 19, D still won, yeah. So see, it came out 16 to 19. So they like anybody better than A, it seems like, right? We just had the crowd match up 1-to-1, and A, they always prefer whoever else over A, don't they? Okay, keep going. Now we're going to do B versus C. So come on up here. Oops. B versus C. And so the 14 people, they prefer C, don't they? You guys with me? See how I'm doing that? You tracking with me? And then the next 7 people, see, they prefer B, don't they, over C? The next 5 prefer B. The next 5 prefer C. I think that's victory right there, isn't it?
Yes.
Yeah, and the last 4 want B, but that's not enough. So C won that battle. So far, C's the favorite in this method, right? C's not lost. Is this okay? Questions? Feel free to speak up if I'm losing you on what I'm doing. I'm just adding up till I can tell which one they prefer. Okay. Next, let's do B versus D. We only got 2 more to go. B versus D. So the 14, they like D. The 7, they like B. The 5 like B. The 5 like, we're just doing B and D. So they like D. Oh, that's it. D's got it. Once you get 19, you got it. Right? I think. Unless I'm missing something. The last 4 like B, but that's not going to be enough. Yeah. This is 19. So that's more than whatever this is. 16. So D. All right, so look, it comes down to C and D, doesn't it? C and D have not lost. It's like a tennis tournament. They've beaten everybody. Now we need the 2 biggies to face off. The C and the D. C versus D. Here we go. So, ready? The 14, who do they like better? D, that's what always helps D, gets that first 14. The next 7, oh, D's already got it. Look at that. D's killing them. The next 5, C, but it's just too little too late. The next 5 is C. The last 4 is C, but no way. That's only 14, and this is 21. D beats everybody. So there's a strong argument to be made there that D is the favorite candidate. In one-to-one comparisons, you would say to the people, look, people, I had them stand up one-to-one, and every time I had anybody stand up with D, you said D's our favorite. We prefer D, right? So for that reason, we give D the top rank. D, in fact, we would say D won 3 times. C won twice, so he gets second rank, right, here and here. B won only once, so he gets third rank, and A didn't win any one-to-one comparison, so he's ranked 4th. That seems pretty fair, right? Just all the one-to-one stuff. The funny thing is, didn't the point system seem real fair also? The board account point system, but look, they put D second. Is that kind of funny? By the point system, C actually beat D. So which one's more fair? Which one is really the will of the people? Well, either one. I mean, there's no right answer here, really. I mean, there's just different methods, and it's all about your sense of fairness. We're just kind of saying which one seems more fair, and there's really not a hard, fast answer. They're different systems. They gave different winners. Well, all the methods gave D as the winner except for the point system, huh? The point system gave it to C. Kind of weird. D won all the, if D did not win the election because of the point system or whatever, I could see D feeling like, that's not fair. I'm preferred. I'm preferred to C. Like, you're going to give the election to C instead of me, but when C and D stand up face to face and you ask the people and they vote just on C and D, they prefer D. So how can you be giving the election to C? And of course C would say, well, when you do all the points, I get more points. So, So what math attempted to do with this is come in and make a system that would be fair in determining the will of the people. What they found is none of these methods are fair. Let me just give you the conclusion to the matter. When I say none are fair, what I mean is there's problems with all of them. I've shown you problems with 2 of them already. I'll show you the rest of the problems now as well. So we've already seen with the original method, just simple plurality, like how we vote president. That's not fair because it doesn't think about your 2nd, 3rd, 4th place choices. It's got a problem to it. I mean, it's somewhat fair, but it's somewhat unfair. The point system seems so fair at first. We can see right here it doesn't seem fair. But also, I told you, if somebody drops out, an unimportant candidate, remember we saw that example, then it'll shift the winner. That doesn't seem fair. And then these two methods also, the last two we just did, the round-by-round elimination, and now the one-to-one pairwise matchups, they can do strange things also. In fact, let me give you, did I already give you the handout? I did, right? Give you the handout. Look, you guys have that handout? Grab that out. If you don't have one, I got some extras. And let me show you now the story. It's on the handout. Who needs, how about you pass that down, please? Anybody else? Pass that down. I just need one. Go. Everybody got one? Give me one. Got that handout? Yeah. So remember for the exam, got it? Okay, thanks. So for the exam, we're going to take, well, practice exams in a week, next week. What you get a 3x5 card. Did I say that already? You get a 3x5 card for each of our exams, right? Anything you want, front and back. For sure, what you want on this card, anyway, for this exam, is this table right here. See this table on page 3? This table is like a golden tablet. You want it. You want it. It's golden for your points on the test. Put this thing on one side of your 3x5 card, because it'll answer a bunch of questions for you. Let's take a look at what it says. So it's showing the 4 different methods: plurality, board account, plurality elimination, pairwise comparison. And it's telling their strengths, you know. And then over on the right side is the weaknesses. Let's take a look at the weaknesses now. So the first one, plurality, it does not consider other than first choice. We talked about that. And it violates the Condorcet criterion. That's a French word, that's why it's pronounced that way. So now what's the Condorcet? If you look up above, actually you should probably put all of this on your 3x5 card. You might want to rewrite these in words that make more sense for you. Well, Condorcet, as it says up there, it says if there's a candidate or alternative that wins in a one-to-one comparison between it and any other alternative, that candidate should be the winner. In other words, it's what we're looking at right here. Let me say it in more simple words. Look at this thing. If you're D, look at what just happened. D says, look, I stood up with A and D. Me and A stood up here and we said, who do you people prefer? Just the two of us. They voted and they preferred D. Then I stood up with B. They liked me better. Then I stood up with C. They liked me better. I was preferred over every candidate in a one-to-one stand-up. Okay, right. So I should win. Doesn't that seem right? That's called a Condorcet candidate. We would say D is a Condorcet was some French guy who basically said, look, if there's somebody who wins all the one-to-ones, that person should win the election. That just seems fair. And it does. It does seem fair to me, too. So he would say board account is a bad method because it violates fairness. See how it did not give D the win? Well, that's what we're seeing here. Plurality can also do that. See what it means by violates Condorcet criterion? Means it violates our sense of fairness. It has the ability, it didn't this time. This time, the first method, we're talking about the first method right now, plurality. The plurality did give D the win this particular time. But there are times, there are situations where you're going to have a candidate like D who wins them all the one-to-ones. You know, method 4, he's the winner in all the one-to-ones. And yet the plurality method won't give him the victory. Didn't happen this time, but it can happen. That's what we mean by plurality violates Condorcet criterion. It can break our sense of fairness according to the Condorcet criterion. So it's a bad method for that reason. I mean, it's okay, but it's not perfect. It's got some weaknesses. Is that making sense? Am I communicating about that? Please ask. I'll show you the practice exam. It's going to probe you on these kind of questions. So it's not just, so I want to be clear. I don't want to fool you in any way. That's my teaching. I aim not to surprise you. And we'll see the practice exam next week, so you'll know exactly what I'm talking about. But even in advance, it's not just add up the numbers, what are the methods, okay, I understand everything about the chapter. No. It's this is a college level math class. We're expecting logic and subtle thinking, right? So it's more than just can I do those basic methods. It's do I understand the logical relationships that exist between these different things. You'll be probed on those kind of questions. You'll see the practice exam next week. It's actually already online. You can look this afternoon if you want. But anyway, so they'll ask you things like, does the plurality method violate the Condorcet criterion? So you'll have to know what those words mean, know what we mean by violate, all that stuff. Of course, this table tells the answer. You'll have this. You don't have to. I'm not into you memorizing. You'll have this on your 3x5 card. You just have to logically know what that means. Yeah. Plurality can violate the Condorcet criterion. It can seem unfair. How about the next one? How about board account? So this was the point system here. Look what it can do. It can violate majority, it can violate Condorcet, and it can also violate the independent. See those three in the box right there? So there's three methods. These are all listed up here. And then the third one, plurality of elimination. So I haven't told you about the last two, why they're unfair. Well, here it is. The third one, it violates monotonicity and Condorcet. So the third method can also, let me just say the Condorcet again, it can also, now it didn't this time it did give D the victory. But there are scenarios in which you can have somebody win all the one-to-ones, like this guy did, and the third method, the plurality with elimination, the round-by-round thing, that the Olympics do, won't give them the victory, which seems bogus. Are you kidding me? I'm the one-to-one favorite in every situation, and you give somebody else the victory? It can do it. That third method can do that. So that seems unfair. It can also violate monotonicity. That's the only other one I haven't talked about. Monotonicity says if a candidate's the winner, and in a re-election, all the voters change only favorable, can that actually make you lose? That can happen sometimes. Did you understand the scenario? So no, there's an election. A lot of times what they do in real life, this is how it would happen. Say you got a company or a situation in which you're about to elect. And what they'll do is they'll do what's called a straw poll. Meaning they just ask everybody, hey, if we're about to vote, this isn't official, but just write on a paper who you are planning to vote for. Because they want to kind of get a feel for where everybody's at before they do the official vote. It's called a straw poll. So they send it out, they collect it, they add it up, and they say, oh, it looks like A's going to win. Most people said they're going to vote for A. When the actual election happens, you know, da, da, da. Sometimes when they do a straw poll and they let those results out, what will happen is, if you were going to vote for a candidate that was going to lose, and you see that somebody else is going to win, sometimes you change in favor of that person. You go, you know what, I'm just going to join the winning team anyway. A's going to win anyway. I kind of like A. I'll just change to A. So that happens sometimes, which, okay, sure, that's fine, no problem. A's already going to win, so A wins even better. Whatever, who cares? Well, actually, sometimes in the shift, which is only favorable to A, some of these systems can actually then make A lose, even though only more people, it doesn't seem like, really? No way. Yeah, and that doesn't seem fair, does it? Some of these methods, even though people shift and even vote more for A after the straw poll information comes out, it can cause shifts in the kick-out rankings and all the things that we do in these methods, and then all of a sudden A will lose. That doesn't seem fair at all. That's called monotonicity. And plurality with elimination, round by round, can make that happen. It can actually do that. All right, and then the final one, pairwise comparisons. What's bad with it? It violates independence if irrelevant. That's the dropout. You know, remember somebody drops out, changes the results. It can do that same thing. This last one, this one-to-one thing. Why isn't it the best then? Because it can do that crazy thing where somebody drops out. The one-to-one thing, if you can have a winner, but then we go, wait, hold on, we realize candidate B was cheating on their taxes, so they can't become president. Kick them out, let's redo it. All of a sudden the winner's somebody else. When B was a nobody, remember we talked about that one the other day, that's the same thing board account can do. This new pairwise can do the same bad thing. A nobody drops out and it changes the winner in the end. That shouldn't be, right? This method can do that. So, enough said. All of that is to say, none of these are perfectly fair. None of these methods are perfectly fair. They can all do things which we would say that's not fair in various situations. And not only, and if I can, that's the bad news. And now, what do they always give you after the bad news? The good news. But I'm going to give you the worst news. That was the bad news. Now here's the worst news. And the worst news is not only are none of these four methods fair, but there never will be a fair method. It's not just a matter of they need to keep looking. It's been mathematically proven to be impossible to create a perfectly fair method that won't violate any of these. Doesn't it seem crazy? Like, how do they know there's not one out there? Maybe they just haven't looked enough. No, there's a whole area of math called existence proofs. You can prove if something would be possible or not. And it was a somewhat recent result. This is somewhat new math, like last 30 years. I mean, a lot of math was the 1800s, calculus, algebra. That was all proved in the 1800s. But this is like 30 years ago. Somebody named Arrow, well, maybe 40 or 50 now. Arrow, I think it was 1970s. Arrow proved that it's called Arrow's Impossibility Theorem. And it's on your sheet somewhere. Where is it? Second from the top. Very first page. Second from the top. The very first page. Arrow's Impossibility Theorem. He proved that none of the math, basically that says there never could be a fair method. Any method you could ever come up with will have one of these 4 criterion violated. It's impossible to come up with a system that doesn't do that. So that's the worst news. I gave you the bad and then the worst. There is no such thing as a perfectly fair voting system, and there never will be. There never will be. So how do you determine the will of the people? Well, you pick the method you think is most fair, and you kind of go with it, and you realize it could do some unfair things. That's the best we can do. So that's math's effort to try to make voting more fair. It's kind of a so-so result. Like I said, there's different places in society where they use these different methods. Questions on any of that? That's pretty much our... Oh, no, I got to show you those trick ones, don't I? Yeah, shoot, I want... Where do you go till 2:45, right? Okay, I want to start chapter 2 today. All right, there's a couple. So we finished this one. Let's take a look here. It's a tedious one, though. So I'm going back to number 3 now. Number 3 is one of these pairwise. It's the 4th method, the one we just learned. Where is it here? It's, pairwise. There it is. See, they want us to do pairwise. They want us to do pairwise. So, how do you do pairwise? Well, notice, guys, there's 5 of them. That's a pain. That's why this problem's a pain. There's 5 of them, not just 4 of them. It's not just A, B, C, D. It goes further. That adds, you might think, oh, just one more. No, watch. It's a lot more, therefore. So, okay, so what are they? What are we going to call them? Well, they got the letters here. R, J, so Romeo and Juliet, Julius Caesar, Macbeth, Hamlet, and Taming of the Shrew. So, take those 5 letters and do all, let me write them over here. R, J, M, H, T. Okay, and do all the one-to-one matchups, right? This is the pairwise thing. This is the one-to-one thing. All right, so here we go. R with J, right? I'm just going to go down the line. R with M, R with H, R with T. So R's done, right? Remember, do it with a system. So I just did R with R. It's like A, B, A, C, A, D kind of thing, but it's one more. Now, R's done. Now who do we start with? J. We're going to go J. Remember, you never need to go back up because you've already done the ones previous. Just go down. So J, M, J, H, J, T. J, M, J, H, J, T. Everybody see that? I just went down the line. Y'all with me? Is making some sense? So what I'm doing, I'm doing the one-to-one matchup thing we just did on the last one with A, B, C, D, kind of like tennis tournament, round tennis tournament. I'm just taking the thing, what we're voting on here is what book people like best in their drama class, right? So there's Romeo and Juliet. So these letters represent different books. And so I'm doing, so I'm just doing, they're like candidates, but they're books. You know, everybody's voting on which book they like best or whatever. So you start with the R, and I just went down. I just went R, J, M, H, T. So R, J, M, H, T. So basically, I'm going to have a battle between R and J. I'm going to ask the class. This is the class, the drama club. Hey, drama club, would you prefer to do Romeo and Juliet or Julius Caesar? I'm going to ask them just that, and they're all going to vote and say, if it just came down to those two, one-to-one tennis tournament thing, who would you prefer? Then, what if it was Romeo and Juliet versus Macbeth? What would you prefer? And then, and on down the line. I'm going to resolve each of those is a lot of work to figure out who the winner is. I mean, it's not the end of the world. Maybe it'd be dramatic. But, so you start at R, go down the line, so R, J, M, H, and T. Then you start at the next one, J, and you always go down, J, M, H, T, but we're not done. So I've done R and I've done J. Now you got to start at M and go down the line, M, H, M, T. M's done, and finally H, T. That's all the matchups. So you got a fair bit more matchups. And then I'm not going to do any more. Sorry. I mean, I'm coming off stairs. I'd be glad to do it with you. I just don't. I need to do other things that are more valuable for you during class time. But maybe I'll do one of them. So let's do the RJ. So I'll do one, and then I'll stop. So let's just do the RJ. So come over here and say, okay, we're going to do the first match. It's R versus J. Who's going to win? Well, let's see. I don't know. These 20 people, if it's just R and J, there's R. They like J better, right? They're like, we'll take J. All right, the next 20 people, if it's R versus J, they like R better. 20 for R. The next 16 people, bless you, R and J, who do they like better? J. We good? Everybody see where I'm getting these numbers and everything? The next 12, if it's just R and J, they like J. So I think J's got it at this point, don't they? The next 12, they want J. Oh, yeah, J's for sure. I'm not going to do it anymore. Just go until you can tell who wins, right? J, it's like how you watch sports on TV. I don't know if you know. I watch it, I can tell who's won. Sometimes that's it, right? So J has won, right? Clearly J has won. Then you got to keep going. You got to go through all of them and decide the winner and the whole thing, right? So it's just a little bit longer because there's 5 of them instead of 4. Remember we had A, B, C, D before. This is 5 of them. All right, that's the same thing though. For the rest, I'll go dot, dot, dot. But come by and see me. I used to hate it when math teachers did that, but no. Come by and see me. I'd be glad to finish it off, Sarah's, with you. Better do that. All right. All right, so an election with 5 candidates is decided, method of Pairwise comparison, blah, 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 blah. Okay, how many points did each candidate get? Remember, 1 point for a win, half point for a tie. Yeah, oh, I didn't tell you, if they tie, they get a half a point. We didn't have anybody tie. Yeah, I forgot to mention that. If 2 candidates tie, like if it's exactly a tie in the vote, they get a half a point each. Kind of like hockey does that, I think, right? Hockey, you get 1 point for winning, no points for losing, half point for tie. I don't know. I've heard hockey does that. I don't follow hockey close. So soccer, do they do that? I don't know. Whatever. This method does that. It's a half a point for a tie. So here we go. So what they're doing is they're asking us backwards. This is a trick question. This is what you do have to do a little bit of. Not quite. I'm not going to push you quite this hard on the test, but similar. You'll see. You'll see the practice exam next week. But it's using logic. It's not just straight ahead. It's it's a college level math class. So we got to use some logic. Let me show you. Let me help with this. So 5 candidates, and they're doing the pairwise, the tennis tournament thing, the 1-to-1. Suppose that A loses 1. So here I'm gonna come over here and make this a little bigger. A, B, C, D, wins, losses, ties. Okay, so A loses 1. So A loses 1. B loses 3. So B loses 3. D loses 1, ties 1. Well, why did I write D twice? D loses 1. Keep this like this. D, what did D do? Lose 1, tie 1. E loses 2, ties 1. Oh, there's an E. E loses 2, ties 1. All right, I wrote in stuff there. We good so far? Now, I'm going to fill in no ties here because they didn't tell me those tied. Now, let me ask you this, guys. How many games does each of them play? This is a tournament, 5 people in the tournament, A, B, C, D, E. If you're in a tournament with 5, you just think real life. You're in a tournament. You and 4 other people. 5 of you total. You're going to play everybody else. How many games are you going to play? 4 games. You're going to play the other 4. Right? You with me? Like A, for example, is going to play B and C and D and E. Right? Everybody's going to play 4 games. What that means is these numbers on any row must total 4. Because there's a total of 4 games, huh? A's going to play 4 games. So if A lost 1 game, how do you win? How many do you win? He must have won 3. You with me? See how I'm coming up with that? 4 total games. And then B, what do you think would be? B lost 3, didn't tie any. So how many wins for B? 1. Must be 1. Just fill in what's missing because we know 4 games total. Everybody competes in 4 games. They all play the other 4. Right? Next, C, no ties. So, I don't know either one, do I? Let's skip it. Let's go to D. D, 1 loss, 1 tie. So how many wins for D? 2, must be 2. We good? You tracking with me? So now we're kind of thinking it all backwards. This is where they push us a little bit logically. Okay, and then E, 2 losses, 1 tie. 1. So 1, right, for 4 total, yeah. 1 win there. Okay, now, what do we do from here? Okay, I'm thinking. Here's what I'm thinking. wins and losses must be equal, right? Because in a tournament, anytime somebody wins, then somebody lost, right? So whatever this adds up to be, it must be the same as that. Makes sense? Because wins and losses can't be different. When they tie, they both tie, so that's not a win or a loss for either one. When somebody wins, there's a loser, right? So every winner also has a loser. So what do these add up to be? 4, 5, 7. This has 7, and that's also 7. So my point is, these two missing ones that I don't know about, they can't be different numbers. It cannot be like 3 and 1, because that would make wins and losses different. It's got to be 2 and 2, doesn't it? It's got to be 2 and 2. Make sense? Because wins has to equal losses, logically, when you play a game, right? There's not a winner. Yeah, there was a winner, but there was no loser. No, well, that's just not really possible, right? So it's got to be 2-2 there. See how we came up with that? So I think now we can answer all their points. Their questions? What's the point? The points, as they said, it's a win is 1 point and a tie is a half a point. Just like a hockey thing. So, therefore, how many for A? What are the points for A? Yeah, 3. The 3 wins A got. Nothing for your losses. How about for B? How many points did B get? Just 1, because he won only 1 game. With me? C. How many points does C get? 2 for his 2 wins. Nothing for your losses. D. How many points does D get? 2.5. Yeah, we all good with that? Because 2 wins and then the 1 tie you get a half point for. So 2.5. I don't care. 2.5, 2.5. I think they probably want the decimal. 2.5, 2.5. And then E. How many points for E?
1.5.
Yeah, 1.5, 1.5. Because 1 win, 1 tie. There we go. So that's what they want. They want the points, so they want you to type these in. And we're done. Is that good? So a little bit of kind of thinking it backwards and using a couple logical steps on that. Okay.